Thank you. And thank you, Bruno, for putting together this event. I'm just thrilled to have my own intro animation. That is awesome, as is a lot of the materials prepared for this conference. So I am on the Twitters. If you have any comments or you want to ask questions, feel free to use that. I have a pretty simple message for you guys today. At least I hope it's pretty simple, which is we can get closer, we can get the people that are out there in the world closer to the things they care about than ever before with the new technologies we have out there. And I think the tools are in our hands to really design experiences in a different way. That's what I want to talk about today. I'm going to start out with a picture of Tokyo. I'm kidding. This is actually a circuit board. This is the thing that runs the stuff behind the scenes in what I have out here. So when you're checking your emails, when you're designing great websites, or when you're on the Twitters, stuff like this is behind the scenes. And thanks to the whole notion of a user interface, we never really have to interact with this stuff. Because the role of the user interface, as Bill talked about earlier with the kind of magic and illusion, is to hide this stuff away, to abstract this stuff out of sight so that we can actually focus on the things we care about. But as technology has changed over the years, and I want to thank Dan for setting that up, we've gotten better about abstracting stuff away. So I want to kind of walk through a little bit of a history of the levels of abstraction we've had to deal with to call out where I think we are emerging to and why I think that's actually exciting. So, anybody know what this is? Punch card, right? So this was an early solution for abstracting away sort of the inner workings of computers from people. And from the 1900s to the 1950s, punched cards were really the primary medium for data entry, data storage, and processing, and so on and so forth in computing. But when you worked with punch cards, there was a lot of layers of abstraction that you actually had to deal with. So punched cards were things that lived outside the computer. They had their own specific formats. And in fact, it was actually pretty ugly. What happened was if you're a programmer who wanted to run some sort of process on some sort of content you cared about, right? I'm going to abstract content and process for a second. You wrote on this thing called a coding sheet. You'd write your code out, if it's Fortran code or whatever. Somebody, possibly not you, depending on the size of your operation, would enter that code onto punch cards on this key punch machine. Those punch cards that were created would be organized into these decks, and the first part of the deck would be the program, the second part of the deck would be the actual data that you ran things on. It would get fed into a machine, and maybe after a day or maybe after a long amount of time, somebody would put the output that the machine gave you into your little mailbox. You'd go to your mailbox, you'd take this paper, and that would be the output that you got from this machine. So while the actual inner workings of the computer were abstracted from you, there was actually a pretty big gap between the input and output, right? There was coding sheets, key punch machines, card readers. You were several levels away from the content you wanted to interact with, and you were even further away from what that content really represented in the real world. Along came command line interfaces. And with command line interfaces, when I say command line, I don't mean calling up the terminal on your Mac today. I mean the whole operating system was command line. And basically here, we reduced a lot of the levels of abstraction. You could actually put input into the computer directly through a keyboard. And you could actually get output directly on the screen for the keyboard. But there was still a lot of abstraction that remained because you had to learn all these specific commands and syntax, and the objects that you were interacting with and the applications you were sort of running were hidden from you. They were invisible. The only way you could get at them was through these cryptic text strings like vflip or upright or rotate dash contents. So even though these things really reduce the gap between input and output, because you're putting input in the computer, getting it out on the computer, the things you were manipulating, both in terms of the content and the actions, were still hidden behind these cryptic text commands, and they were still very far removed from what they represented in the real world. So then came the graphical user interface, and the graphical user interface really made a lot of these invisible elements visible to you. So in a GUI, you could see and interact with representations of documents, of applications, of the content and the processes you're running. But there was still a decent amount of abstraction that happened. And in particular, when you're using a GUI, you're really manipulating a bunch of icons, windows, buttons, UI controls, so on and so forth. And so you had to learn how these components work. You had to understand them because they were the only way to provide input into the system. It was visual, and it was a lot more interactive, and you had direct manipulation. But with the GUI, and this is a screenshot of my desktop, you spend a lot of time moving windows around and clicking on icons and tapping all these things, right? You spend a lot of time interacting with the elements of the GUI versus actually interacting with content. And again, you're still a little removed from the real world. But this, once again, sort of reduced the layers of abstraction we're dealing with. Now, to illustrate this next transition, I have a video of Google Street View navigation. So you'll note Google Street View navigation in this instance has a very traditional GUI. They have some controls on the screen, and you click the GUI, click to move around, right? And after a while, it gets pretty tiring. So what they did instead now is they actually made the content itself the interface. And now you don't go clicking on these little arrows all over the road. You actually touch on the building when you want to go to, and you move around in. And here, this shot of the Netherlands, you kind of move in and out, and you start flowing around, interacting with the actual content. The content itself has kind of become the interface. There's still some elements of GUI in here, but this is really, I think, representative of this shift from a graphical user interface to the term that's kind of being thrown around a lot now, a natural user interface. And when I think about natural user interfaces, I think they try to go one step further to eliminating this layer of abstraction because they get rid of the whole windows, icons, menus, pointers to a certain degree. You'll note even in Apple's iPhoto app on the iPad, there's still some GUI controls and things like that. But they go a step further and actually let you use your hands and let you actually manipulate the content. So if we look at the process of using the Photos app on the iPad, you see you're actually interacting with the content itself. You're not using this pointer. You're using actual physical, quote-unquote, realistic controls to expand things out. And you can tap on a single one. You can just move the list by touching the list. You don't have to touch a scroll bar. You touch the photo, you move the photo, and so on and so forth. Right? So these things eliminate yet another layer of abstraction. And the interface really tries to use guessable physical gestures, kind of the stuff that Dan was walking through in his project, to let people interact with stuff. And ideally, a natural user interface takes advantage of skills you've learned through a lifetime of living. This is how Bill Buxton, who's been working on this since the 80s, really describes it. When I was at Microsoft's Mix conference, Bill Buxton had a painter, someone who had been a painter his whole life, using a 4x4-foot multi-touch screen to do painting on this experimental Microsoft research project called Raphael. And he would draw and blend exactly the same way he did on canvas. And the software really tried to adapt itself to the way physical materials work, as opposed to introducing a lot of controls to learn. So when you're using these natural interfaces, there's a whole bunch of gestures that are sort of emerging right now. Different software or different hardware platforms and software platforms refer to those gestures differently. Me and a few friends recently did a catalog where we looked at all these different touch platforms and we analyzed what the common gestures were across them, and we did a breakdown of what are the user needs and goals that each of these gestures supports. And you can get access to that online. So for example, if somebody wants to adjust something, this is a common gesture for doing that. So that's kind of natural user interfaces. And once again, we see us really breaking down the barriers, right? So when we started with punch cards, you had to write coding sheets. You had to use key punch machines. You got them in computers, and out came this printed output. With command line, you could provide input and output directly on the computer, where you had to learn these commands. With GUI, you get to see those objects. And with NUI, you actually get to touch the content. And more importantly, you're interacting with the content itself. So we've been gradually reducing these layers of abstraction, getting ourselves, I think, closer and closer to the content we want to interact with, and especially what that content represents in the real world. Because basically all this stuff boils down to stuff that's in the physical world that that can be enhanced. And I think the way we get even closer to this is a first-person user interface. And I'm not trying to introduce this as a new form of UI, but I think it's very useful to think about how do you design an experience with this further level of reduction. And I think that helps us get people even closer to actually interacting with the things they care about. Now, of course, programmers are going to use command line for quite a while. GUI's not going away anytime soon. But for many people who have ordinary needs in their day-to-day lives, reducing all that abstraction further and further can go a long way to empowering them in what they find valuable each day. So, what's a first-person interface? Essentially, a first-person interface is an application that layers information together with people's immediate view of the world. So my current view of the world right now, I can interact with that digitally. And basically, they give you relevant output based on where you are, who or what is near you, and they can turn things that are around you into networked interactive objects. So that means you get all the good parts of digital with your current situation in the real world, as opposed to having to tell computers over and over again where you are and having all this abstraction. It starts with a series of always-on sensors. And so the first sensor that's really important to this is location detection. And there's a number of technologies that can detect your location. But if we know where you are, we can do simple things. Well, in the past, this was futuristic. But now we can basically say, hey, here's what's near you. And there's a number of ways that we can locate you. The location technology has gotten better and better. Right now, many devices come with all of these location detection capabilities built in. So, for example, a regular smartphone will have GPS, Wi-Fi triangulation, cell tower triangulation, so on and so forth. And there's different levels of accuracy that you get with each of these areas. And in fact, web browsers are now supporting this and so on and so forth. But it gets a lot more interesting when we can actually know your perspective as well. So in addition to having a location detection sensor, many devices now also have an orientation sensor, which is essentially a digital compass or a magnometer, as they say. And maybe the simplest thing to imagine here is if I know where you are and I know what direction you're facing, I can give you this kind of view of the world, right? Letting you peek into the things near you and having digital information around you. So those are two things, location detection and orientation, but there's actually a whole bunch of other sensors that are being built into modern computing and especially mobile computing hardware. There's device positioning, audio input, video input, connections, proximity, ambient light, RFID readers, and I'll talk to some of these, especially audio and video input. But all this stuff enables you to take in input sort of behind the scenes when people are in the real world and transform them into instant relevant output. So if we look at a first-person user interface, it's passive interaction. It gives you instant relevant output based on your position and or who or what is near you. So we can look at several examples of how a first-person interface makes use of these sensors and how they allow people to digitally interact with the world as they're currently experiencing it. The first one is navigating the space around you. And this is a use case that's probably pretty common to a lot of people given the technologies that are out there now. But basically, we've had navigation tools in the form of GPS units for quite a while, right? And early GPS units would use this location detection technology plus the direction you're generally moving in, and they'd pinpoint you from overhead on a map. A couple of years ago, these representations started to take a transformation, actually had this three-dimensional worldview as you're moving through space. So that meant that the navigation cues you were getting were actually designed from your current perspective. And this sort of spatial navigation became more widespread. In fact, the latest version of TomTom's navigation system goes even further to mirroring your perspective of the world, which hopefully makes things easier to follow in terms of a route. Because when you're in motion, kind of seeing the world as it currently is helps you stay on track. So this really starts to match your physical surroundings. But Google's Street View navigation and Google Maps on the Android platform can actually use real-world imagery to highlight where you're going, right? And so here what you're actually doing, instead of redrawing the world around you, what they're actually using the real world around you and overlaying navigation information on it. So this puts actual images and directions directly on the interface that you have, and you can run this on an Android phone, use it in the car, or use it while you're walking, so on and so forth, through Google Street View. Okay, so that's kind of one use case, is really letting people make their way through physical space using this information. But not only can these interfaces help us move through the world, they can also help us understand it. So this is where we get into things that people dub augmented reality. And augmented reality, again, to quote kind of Dan's talk, has been around for years. I think it's about 17 years old or something like that. And it's kind of coming into fruition, but as we'll see, the experience is not really so great yet. But the general idea is that there's information and applications that can overlay the world around us, thereby augmenting our view of reality. And essentially they will enhance the real world with information you can't see with the naked eye. So this is for those of you that aren't familiar, I'm sure a lot of people know this, but this is a really simple example. This is an app called Nearest Tube, and it just shows you these subway lines near you. You can kind of point it at the ground. It'll show you how far away each subway line is near you. If you move it up, you get kind of a different view. And here you can see, generally what direction things are in. If you shift it up even further, you can see other stations nearby. And when you move it up higher, it goes to things that are further away from you. When you have it right in front of you, it points to things that are closer to you. So this application augments your immediate surroundings by giving you additional information. And it's important to note that it actually provides different information based on your orientation. So this is kind of part of this first-person user interface. Depending on how you're actually looking at the world, it adjusts itself and changes things around. So if you're looking up, it'll show you things that are far away. If you're looking down, it'll give you this sort of arrow view. And if you're looking straight ahead, it'll overlay things on the map as so. So making use of these multiple perspectives, we naturally have a number of perspectives available to us when we're in the real world. We can look down, we can look ahead, we can look up. And it allows these interfaces to interact with software in a way that's guessable, physical, and realistic. Now that's a useful example. Here's another thing that I think actually is a useful example. This is called Augmented Outdoors. If you're out in wilderness, it'll kind of point out mountains near you, and how far away they are, how tall they are, and what they're named. So if you ever wonder what's the name of this application, you can use this thing. Here's one for finding a place near you to eat. So instead of seeing everything on a list or an overhead map, you get data overlaid on your field of vision. Now this is where I'm going to pause and say, okay, this seems like some kind of little fancy UI trick, right? Yay, I can take the camera and overlay a couple windows on it. And that's sort of what I was thinking for quite a while. Then I actually heard Jeremy Stoppelman, who's the CEO of Yelp, talk about what happened with people that use this feature on Yelp. And he said that they boosted their sustained traffic by up to 50%. And the people at Yelp were actually floored by this. They said, this just blew our minds. We had no idea that this would actually be something people interact with and use. They treated it as an Easter egg and as a surprise inside the application. They never thought it would be a dominant interaction paradigm. So what this leads me to believe is that there's something interesting here. And although it's really awkward to have all of these different windows pop up on here, as I'll talk about in a second, there's something really compelling about having this immediate augmentation of where you are in the real world right now associated with what you're trying to do. So looking at this in a little bit of depth, this is an early example. I think it was one of the first augmented reality experiences I saw, and this was running on very early versions of the Android phone. This was on the G1. This is called IBM Seer, and what they created is an application for the Wimbledon tennis tournament where you could see not only what things were near you, but it would give you these little updates. Queues are kind of died down right now. Taxi line, 2 minutes ago, it's kind of busy. A lot of people trying to go home. You could click Take Me There, and it would navigate you to that area. And this example, I think, introduced some of the early interface paradigms that follow a lot of these apps. So if you take a look at what they have in here, they've placed markers on the areas, and they have different kind of icons representing different things on the markers. They have this little overview panel which shows you how many things are around you in the direction you're facing in, and it highlights the specific marker that you currently have active. And then it has a little data window that actually gives you the content when you interact with one of those markers. Now this can quickly get out of hand, especially on a 320 by 480 display. So look at all those markers and look at all those dots and overview and orientation of that space, right? This is basically unusable at this point, at least to me. Maybe it's because I can't read it. So there's a couple things that people in this space have been trying to do with the interface. Wikitude, which is a system that overlays Wikipedia information on the real world. They have markers, they have a data window, they have this overview and orientation, but they also have this zoom scale bar. So you can zoom closer or further out, and that helps you manage the information in front of you. And I think that helps you kind of focus in on whether you want something further in, further out, so on and so forth. Layer, which is an actual browser of augmented reality stuff out of the Netherlands, and they're on their third version of this now, so they've been changing the interface a couple times over. What they do is they keep this data window in a fixed location, so it's not moving around all over the place and blocking your view. They have this spatial grid overlaid on the screen, which I hope you guys can see. It seems a little dark up there. But it's essentially a grid that shows you how far away things are, and they scale the icons based on how far away things are. They've really made all their user interface transparent. So now from version 2 to version 3, you can see how much of the display is actually your world view. And they have the option to lock a certain display, so as you move around, what you're looking at doesn't go away. So that's pretty useful. Another thing that people have been exploring, this is an application called Yell. They'll allow you to actually lock one of these points of interest on the screen. So again, you can keep that together. And this is something called nearest tweets. And what they do is actually stack things vertically, which I think seems a little clunky, but people are exploring. And so as you can tell from these augmented reality applications, they have some user interface issues. And as a result, I think it's important to sort of pause and put this in the context of the things we looked at. I think these first-person interfaces are very much in an emergent area. That is, people are trying to figure them out, which I think creates a huge opportunity for designers, right? So the technology is there, but the actual ways to utilize that technology are pretty rudimentary right now. Consider something like natural user interfaces. These things are very much in a growth stage right now. So every major hardware and software vendor from Microsoft to Nokia to now BlackBerry with RIM 6.0, Microsoft, Apple, Google, everybody's shipping touch-based devices and sensor-rich devices right now. In fact, just between Apple and Android, there's 192,000 touch-based devices sold per day. So this is very much on a rapid growth rate. Graphical user interfaces are pretty mature. There's not a lot of motion here, meaning if you're a Windows user, you're probably a Windows user. Maybe you'll switch over to Mac, and and then there's a few hardcore Linux people, but roughly there's 2 to 3 players here, and that's about it. And then on the decline, there are applications that use command line, and you can get into the terminal and do some development like that. But as an overall paradigm for interacting with the whole computer, outside of the example Peter showed of someone actually using MS-DOS to manage their finances, these things are pretty much on the decline. So this is kind of the state we're in. And again, I think it creates a lot of opportunity, not only in augmented reality, but especially in the stuff I'm going to talk about now. So if you think the applications for augmenting your immediate surroundings are emergent, this next set of things are also very much in that category. But the two things we've looked at is moving through physical space using digital information and how we can layer that on top of your real-world view, augmenting your immediate surroundings with digital information and actions and how we can interact with that. But then the next thing is actually digitally interacting with people and things near you. And as an example, there's an application out there called Red Laser. And Red Laser allows me to scan the barcode of Bill's excellent book, who's back there, and I can see how much it costs everywhere online. The Shop Savvy application on Android will scan both 2D and 1D barcodes, so you can scan a QR code here. And it then will actually give you this augmented reality view of where you can go buy this near you. You can look at it on a map, you can look at it on a list, so on and so forth. You can also, using an application like Snaptile, take a picture of an object. So again, I'm obsessed with Bill's book. I'll take a picture of it, and I can see how much it costs where. I can get prices about where it is near me. I can look at the reviews and so on and so forth. And so now what I'm using is actually the video sensor on these mobile computing platforms to provide input, right? So I sort of point this phone at something in the real world, and I get relevant output back. I don't really have to do too much else besides point this. And Google has a product out where they're actually taking this very far. So you can point your camera at a product, get information about it. You can point it at a wine label, get information about that. You can point it at a business card, and they'll scan the text and enter it into your phone. You can point it at a work of art. They'll identify it for you. You can point it at a landmark, and using your location and the imagery, it'll identify it for you. You can point it at a foreign language. They just announced this, and it'll translate it for you. Right, so here, sour cream cake with elderberry sauce. Yeah, I guess I'll try eating that. I might not have ordered sorry. So it's taking a lot of different forms of visual input and doing stuff. And in fact, Google has not only started allowing you to interact with those objects, they started placing these things in the United States and in other areas around the world on locations. So when you find one of these Google codes on a restaurant or a building, you can, again, point your camera at it, and it comes back with, here's the menu, here's the ratings and reviews, here's the phone number, make a reservation right now. That becomes very interesting. And Facebook has started experimenting with these QR codes on people. TBD what they're actually going to do there. But I'll show you another example. This is an application called Recognizer from Polar Rose and the Astonishing Tribe. And what it actually does is use facial recognition data from Polar Rose and people's online profiles to bring up digital information based on the people it recognizes. And so here's Mina, and you can contact her, and so on and so forth. Controversial. But so Polar Rose has been tagging pictures of people for a long time, and they have this technology for that. So all that said, first-person interfaces can reduce the abstraction between user interface and the content and actions we want in the real world, because they can let people interact digitally with stuff. But there's some really awkward things going on today. So one really awkward thing is it's a very big world out there, and it's 320 by 480 pixels is a very small screen. Right? So that's why you saw all those issues with these augmented reality browsers. It's just not a lot of stuff to put all the things around you. So it's a pretty big design challenge moving forward. So even though there's all these sensors, they get all this data, putting it on that little screen is a big design challenge. Another thing, when you want to interact with objects or people near you, you turn into a grocery clerk. Now you're scanning and checking everything out, which again is pretty awkward, right? Let me scan this book, okay. Nokia calls this point found. When I see somebody holding up their phone in the street, I say, nerd found. Which is true. So, how do we take this data and this value, and how do we bring it to our immediate surroundings, and how do we do it in a way that's compelling? I think there's a couple things that are pointing the way that's interesting. So, one thing is actually using objects that don't just have physical identifying markers, but have digital identifying markers. So RFID, for those of you that know it, you use it probably every day when you're moving through the trams and the buses and the subways out here in Portugal. It's essentially an electronic identity code, and it has an identity and it broadcasts it out. So an RFID reader can take that identity and do something with it. So this is a video of an RFID reader embedded on an iPhone. And you'll see here the only input that somebody actually has to have. You don't have to do this scan and check out. You can just move it near an object with an RFID tag. And so they move this phone near this car, and a video starts playing that's associated with that car or cartoon. They move it near the hippo, and a video plays associated with that car or cartoon. Right? So a kid who wants to see a video of hippo whatever just points the screen at the hippo, and the video starts playing. No awkward interactions with the VCR, no gesture control, sorry Dan, with the Kinesta. You just sort of move it near the object you want to play, and up pops the hippo video. Apple has a bunch of early work on RFID, and I've been thinking they're going to implement this relatively soon, but we'll see. There was a company that had this little RFID enhancement product. I think the demand was so high that they actually clipped it, because I don't know if they were going to really produce it. But here's an example of just putting things near stuff to get that input. rather than having to scan and do this. Different screens are optimized for different kinds of interactions, right? So for the hippo video, I may just move a remote near the hippo and it plays on the TV screen versus this little 320 by 480 screen. Another RFID application that can now only allow us to interact with objects, it can allow us to interact with locations. So right now there's a lot of buzz around location check-in services, so things like Goala and Foursquare, where you get your phone, you wait for it to connect to GPS, then it identifies a spot, you click the check-in button if you're lucky, right? At Facebook's developer conference, oops, this didn't highlight it properly, but they give everybody a little token, and as you moved around the conference, you just put your token near the little box and it would check you in. And you could take a photo with it, and it would just upload that photo, so on and so forth. So literally what you do is just take that chip and move it past some place that you're entering. And I think if we had things that would allow you just to check into places like that, we'd see a lot more integration. So RFID is a way to get rid of some of these awkward interactions. Another way to get rid of some of these awkward interactions is just bigger screens. So mobile devices like the iPad, this sort of hints at what you can do with a larger screen. When you zoom into where you are in the real world, let's assume this is where somebody actually is, you can get these nice, natural user interface interactions with that view of the real world, right? And you have a much bigger canvas to put this information. You can interact with it through these natural gestures, and you can sort of augment reality in that way. Other field of vision displays that could start to contain this information are these heads-up displays in something like an automobile. So right now, the BMW 7 Series and 5 Series and the Lexus 450 RX have heads-up display UIs on their windshields, and those will display for you the rate of speed that you're moving, and it'll actually show GPS turn-by-turn information as well. They're pretty small little things, so they don't get in your way, but that stuff's out right now. And where we ultimately want to go is this. I'm kidding. Well, you can start to see what happens when you have a pretty large canvas to paint on. So larger, these more passive identity broadcasting systems like RFID allow near-field communication to happen, and then larger screen surfaces, maybe like mobile devices like the iPad or larger screen interactions on something like the automobile can actually help with these first-person perspective interfaces. Now, I'm going to venture into the scientific for a moment, and this is going further back, so it'll probably take a couple years for this to come forward. But bio-nanotechnology experts at the University of Washington have been experimenting with contact lenses with built-in circuits and LEDs. So they're actually already producing small numbers of these things. And what they basically have is a lens with an LED that they're powering wirelessly. And this enables stuff like this to happen. Now, I don't know when this is going to come out or what have you, but it does start to give you another solution to dealing with the screen issue, right? I don't know if we'll be wearing contact lenses that do this. I'm just saying it's kind of interesting. Okay, so enough teases of the future. Let me recap what I came here to talk to you about. First-person user interfaces, I think, are a nice progression towards this reduction of abstraction in that they actually let you get closer and closer to the content you want to interact with. Because face it, people want to interact with the stuff around them, and digital can help enhance that and help augment that and help make those interactions more robust, because generally anything that can be digital will be digital, because it's faster, cheaper, and better, ultimately. So getting ourselves closer and closer to what the content we're interacting with actually represents in the real world has some advantages. It's not for every use case by any means, but it has some interesting implications. And I think we can do that by allowing people to have digital interactions with the real world by navigating, augmenting, and actually interacting with things nearby. But these interfaces are in their infancy. They need help. They need your help. They really need design help. So somebody who wants to care and focus on this kind of class of emerging software, I urge you to get into it and, for God's sake, help fix those augmented reality browser things. And keep us away from that. And if you want some more information on this stuff, I'm on Twitters. I have a blog. If you want to talk about web forms, which is like 3 levels ago of UI, here's 25% off coupon for you. Thank you. guess I have time for a question or two. Anyone have a question? There's one there, one in the back, one over here. Anybody?
Hi. There's a tweet going around that basically the only real natural interface is a nipple, which isn't true because even babies have to learn how to latch on to that.
Yes,
but what would you? I mean, what is a natural interface? Because what is natural when it comes to natural interfaces? Just given cultural differences and behavioural differences in people, how do you define it? There's an argument around that definition. So I'm not Mr. Semantics.
I try to embrace terms that are going around a lot. The way Bill Buxton, who, like I said, has been in this field, in this area probably longer than most people with a design background, describes it is an interface that makes use of skills you've learned through a lifetime of living. So his pinnacle example is what I described at the beginning, that Raphael painting program, which works the way painters work. It doesn't force you to learn any new skills. The materials work the way painting materials work. The blending works the way real blending works, and so on and so forth. So I think that's what he would put out there as a natural interface more than anything else.
Great talk, by the way. It would be interesting. Not so much a question, just a point. I did a project last year about combining a wearable camera with face recognition software to help people remember the names of people they meet. And to exactly your point, it's not about the technology anymore. All the technology is there to do it all. It's all about the user experience. What's it actually like to walk around and take photographs of of strangers? What's it like for strangers to have people walk up to you? There's a lot of good research now about that kind of thing. What are the social conventions? And as a very quick point of the conclusions, to echo your one, it's actually more comfortable to have a passive wearable camera than to actually try and take strangers' photos with a normal camera, because with a normal camera, just like you were saying, you almost have to use the barcode reader on their face. You have to hold up the camera, which is actually quite uncomfortable and strange. When you walk up to somebody, the first thing you don't do is walk up to them and say, "Can I take your photo?"
Yeah.
It's a bit weird. So it is all about the user experience, the social conventions, what's it like to actually do these things. The technology is all there to do it.
Right, and I would say with graphical user interface, natural user interface, we're in optimization mode to a certain extent. Natural user interface still has some new things to do, but this stuff is wide open, right? All the interactions are really awkward, as I said. The other interesting quote that I like to talk to from William Gibson, he said, I think I got this from Dan's book, which is the thing our grandchildren will find most quaint about us is that we distinguish the physical from the real. The digital from the real. Who's to say what's really augmentation after a certain point? The iPad thing, it holds all my books, right? It replaces a number of physical devices I used to have, like this beatbox mixer and keyboard even, so on and so forth. So there's this interesting blend happening at the same time, but there are still real transition issues that are out there. And again, I think Dan's talk spoke exactly to that. Like, how do you map to expectations? How do you use the Maya principle? So on and so forth.
Hi, I'm just wondering about how these type of interfaces are going to affect our concept of privacy, and if the fact that we still consider privacy the way we do, and the fact that our concept of privacy might change slower than the technology, is going to influence the success or failure of these type of interfaces.
Yeah. The privacy question is an interesting one. So the thing I think people, and this applies to that quote I just said, privacy all of a sudden becomes an issue when it's digital, but it's not so much an issue when it's physical. We expose so much of our lives to people every single day, just interacting in the physical world, in terms of where we are, in terms of what we're doing, in terms of who we associate with, so on and so forth. We actually have much more information about ourselves available publicly in the physical world than we have digitally, because digitally there's still a conversion process. So I find some of this stuff a little interesting, and I think it's this transition that's happening. Because in all honesty, if somebody wanted to stalk me, it's much easier to do it physically than it is digitally. You're never going to get everything I do off of Facebook. You'll get these little blurbs and blitz. But it is an issue. People are working through it. It'll be very interesting to see what happens over the next few years. And the other point I'll make there is I have been repeatedly wrong and shocked about how much people will share. Every time something's come up, I've been like, oh man, that's crazy. A year later, everyone's... So, we'll see. Exciting times. Okay, I'm not going to keep you guys from lunch any longer. If you want to ask me questions, I'll be around. Thank you.